Okay, so for this week's problems, it is the problem set for week 8. All right, starting off with number 1. So for number 1, we have, I decided to use the ratio test. And basically, the ratio test is that if the limit of blah, blah, blah is less than 1, then the series is going to converge. Specifically, it's going to converge absolutely. If it's greater than 1, then it's going to diverge. Exactly to 1 pretty much means that it is inconclusive. So starting off, we're going to apply the ratio test right here. Simplify. And so after we get to this equation, right after simplify, we note that the factorial function is growing very rapidly. Therefore, we can ignore the 10 in the numerator and denominator. The factorial function is dominating, basically. So down here, we now have 7 times n factorial over n plus 1 factorial. And that goes to 7 over n plus 1. Now we can solve it out. So basically, it goes to 0, and the limit becomes 0. Therefore, it will converge. Specifically, it's going to converge absolutely, since the limit of the ratio test is less than 1. Okay. Okay, so for the second one, we're going to go ahead and we use the alternating series test. Basically, it says if this series, Bn, satisfies 2 conditions, Bn positive decreasing, and then number 2, n going to infinity, Bn equals 0, then it will converge. So we set as ln n over n1 3, 1 to the power 3, so it's third root. It's positive for all n. So now we set it up 1 over n over 1/3 n 2/3. Why do we get to how do we get to this? Well, I did the L'Hopital's rule. So now we're going to simplify from here to here. So we get 3 over n 1/3, but it equals 0. So both conditions are satisfied if you look at it. So therefore, since both conditions are satisfied, it converges. Okay, so for number 3, we're going to be using ratio test again, and I already explained what a ratio test is, where if this less than 1 converges, to simplify it, really. So I set it up. It's really hard to see. And going to infinity is this. Simplify it to this. I keep simplifying it. And here's this really long one that was kind of annoying. So basically, n approaches infinity. That n approaches infinity term, the terms involving the n in the exponent, basically what they're doing is they dominate. And the exponential term right here, basically that approaches 0. Therefore, so when you simplify, it goes to 0. It doesn't go to 0, it equals 0. So since the limit of the ratio is less than 1, that we can conclude that it converges specifically absolutely. It converges absolutely. Okay, so for the last one, I decided to use the LCT. What does LCT stand for? LCT stands for the limit comparison test. Basically saying n going to infinity, an over bn equals L. A and or bn are positive sequences, and L is a non-zero finite number. Okay? So the series, n equals 1 going to infinity, an, same for bn, either both converge or both diverge. So comparing given series to a known series, bn equals 1 over n, we know that 1 over n, it's a known divergent series. So we can use it. So calculating the limit now, ln 2n plus 1 over 2n plus 4 over 1 over n. And now solve it through L'Hopital's rule. It's a great rule. I like it a lot. It's my favorite because it's easy. So 2 over 2n plus 1 over negative 1 over n squared. So 2n squared over 2n plus 1 equals going to negative infinity. So basically, the limit is a finite and non-zero, well, negative infinity, really. In this case, it's negative infinity. The series ln 2n plus 1 over 2n over 4 diverges by LCT according to the divergence series n equals 1 series infinity 1 over n.